Alright, this is the screencast for 7.3, logarithmics and logarithmic functions. So to the first, right, 2 to the first is just 2. 2 squared, 4, because that's 2 times 2. And then 2 to the third, 2 times 2 times 2, right? 2 times 2 is the 4. 2 times 2 times 2 is going to give you 8. Keep in mind, this is your exponent, and 2 is what we call our base. So the question is, if 2 squared is 4 and 2 cubed is 8, what exponent of 2 will give a result of 6? Right now, 2 to what power is equal to 6? That's the basics of a logarithm, right? To answer this question, we're going to need a logarithm. So a logarithm answers the question of what exponent of a given base will result in a specific value. So if I have something like 3 squared is equal to 9, I want the answer to be what exponent it is. So I say log base 3 of 9 is going to be 2. Because it's like so this is the base, right? 3 to what power is going to be 9? So this is the exponent, right? So this is going to be your exponent, this is your base, and then this is the answer you're trying to get. So if I say 3 to the second power is 9, it's a little curly Q action, right? 3 to the second power is 9, so log base 3 of 9 is 2. Okay, so just giving you a general sense of what this is. Let's explore logarithms. So if we have a base 3, and my exponent's 2, 3 squared is going to be 9. So I put the base below, and then the exponent is what the equals, and it just wraps around. Let's try it. 2 to the 5th power is equal to what number, right? So you have 2 times 2 times 2 times 2. Okay, 5 times. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this means log base 2 of 32 is 5, because your base goes in this hole, then the exponent, and then the answer. So it always goes base, answer, exponent. 4 squared is equal to 16. So I would write this as log base, right, 4 of 16 is equal to 2. And to switch it from exponential to logarithmic, or logarithmic to exponential, you just do a little curly Q action. Ooh, this one's a little difficult. We have to go to exponential now. So you start base is 3 to the 3rd power is going to be equal to 27. Awesome. And the way we write it, right, the way we write it is we say log base 3 of 27, log base 3 of 27 is 3. This is the way in English we say it out loud, right? For the third example, we would say log base 4 of 16 is 2. And similarly, the first one we say log base 2 of 32 is 5. So, definition of logarithm. Alright, so the base has to be greater than 0. It can't be equal to 1, and x must be greater than 0. You can't take log of a negative number. So remember, the answer to a logarithm is always an exponent. The answer is always an exponent. So let's write each equation in exponential form. Give it a shot. You can pause the video, give it a shot. So a little hint to you is log base blank of blank is blank. So log base 3 of 9 is equal to 2, right? Because this is going to be your base, and the answer is always your exponent, and then you have, you like wrap it around. So let me pick a different color. So you wrap it around. So let me wrap this guy around. So I say 10 to the negative 2 is equal to 1 over 100. Similarly, I say 3 to the 6th power is 729. Little seashell spiral action, that's what this is. Remember how I say it? Log base 3 of 729 is 6. And the is 6, this is always your exponent, because the answer to a logarithm is always an exponent. Let's now write each equation in logarithmic form. Woo! So this is my base. So I have log base 5. Remember, the exponent is the answer. So log base 5 of 125 is going to be 3. So this goes here, and then the exponent comes at the end. So base comes here, and then the answer, and then the exponent at the end. So I have log base 27 of 3 is equal to 1/3. And we're going to practice some of this in class. So ideally, really, these screencasts are meant to introduce you. You could try a couple of the problems on the homework, but really I want you to focus on having the basics, coming to class, and then we'll work on everything together. All right, so here's my base, log base 6 of 1/216th is going to be, and then your exponent comes at the end, -3. Right, because here's my base, and then this is my exponent coming at the end. And now lastly, we want to evaluate each expression. So, log base 3 of 243. Let's see. So, log base 3, so 3 to what power is going to be 243? And what do you know? We just wrote what, in a similar form that the last lesson was talking about. The first part of 7.2 talks about how to solve these. So you want to rewrite these so that way they have the same base. So there's a couple ways you could do it, right? So 3 to the first power is 3, 3 squared is 9, 3 cubed is 27, 3 to the fourth power 81, oh my gosh, keep going, 3 to the fifth power 243, got it. So 3 to the y, I'm going to rewrite 243 as 3 to the fifth power, so you see y is equal to 5. So the answer is going to be 5. All right, this is way 1 of doing it, and then there's way 2, which actually gets you the same answer, but that's only if I give you a number that's nice. It actually is a integer exponent. I could give you a rational exponent. That would not be nice. Rational meaning fraction. All right, let's try the next one. 3 to what power is 81? 3 to what power is 81? Ooh, so bring this back. I see to the fourth power. So 3 to the y is equal to 3 to the 4, and once you have the same base, you set the exponents equal to each other. All right, we'll give it another go. Log, let's see, so 1/8 to what power is equal to 512? So I have 1/8 to the y power is equal to 512. Ooh, so this is a trick one. We have to make each of the sides to the same base. So I'm going to pick 2. So why don't I put 8 to the negative y is equal to 512. Actually, does 8 go evenly? Let's see. 8 to the first is 8. 8 squared is 64. 8 cubed is 512. Ooh, just kidding. We don't have to use 2. We can use 8. So I have 8 to the negative y is equal to 8 to the third power. Since the bases are the same, set the exponents equal to each other. You see y is equal to -3. So this is an application of our second lesson, 7.2. Awesome. And next one, log of, let's see. Okay, log, so 1/6 to what power is going to be 216? So 1/6 to what power is equal to 1/216. So let's see, I could rewrite both of these as to the negative power. So I could say 6 to the negative y, because I just make the exponent negative by flipping to their side. And now this is 216 to the -1. So 6 to the first is 6, 6 squared is 36, and then 6 cubed is going to be 216. So picking some nice numbers for you. So I have 6 to the negative y is equal to 6 cubed times -1. So you have 6, running out of room, sorry. 6 to the negative y is equal to 6 to the -3. Same base, I set the exponents equal to each other, and you see y is just going to be 3. All right. I think, is that all? No, we have one more. All right, sorry the screencast is going to be a little long, but we got it. All right, so we've dealt with what is a logarithm, right? A logarithm answers the question of what exponent we have to put a base to in order to be in a certain number. So the answer to a logarithm is always an exponent. We learn how to convert between a logarithm and exponential form and exponential form to logarithmic form. Example 3 is all about putting 7.2 back together by solving. And now we're going to talk about certain properties of logarithms. Alright, especially 0 and 1 as exponents, right? So any number raised to the power of 1 is itself, right? Anything to the first power is itself. And any number raised to the power of 0 is going to be 1. So the exponent property of 0, 2 to the first, guess what? It's 1. So if I say log base 2 of 1, it's just going to be 0. 3 to the 0 power is 1. So if I say log base 3 of 1, that's just going to be 0. 4 to the 0 is 1. So, right, because anything to the 0 power is 1. So I can say log base 4 of 1 is going to be 0, because 4 to the 0 is 1. 3 to the 0 power is 1. This means b to the 0 is 1. So the property is going to be, right, this is the important one, log base b of 1 is going to be 0. Doesn't matter what base you put in there. If you put log base of 1, anytime there's a 1 right here, it's always going to be 0 as your exponent. Okay, and then the exponent of 1. So 2 to the first is 2. So if you say log base 2 of 2, that's going to be 1, because 2 to the first power is 2. 3 to the first power is 3. So I write this as log base 3 of 3, and that's going to be 1, because 3 to the first power is 3. 4 to the first power is 4. So I can write this as log base 4 of 4, that's going to be 1, because 4 to the first is 4. And b to the first is just b. So this is the important one. So we say log base b of b is just 1. So this is useful if you have something like 3 times log base 75 of 75. Oh my gosh, you know what this is. Anytime you have the base and this number right here, the same thing, you can just replace this whole thing by 1. So 3 times 1 would just be 3. This is where properties of these exponents come into play. And that's it for our third lesson for 7.3.